All right, in this video, I want to talk to you all about the other half of your mole map. So, up until this point, you have the left hand side of your mole map filled out. Okay, but on that side, we had Mole Town A, and we could convert between mass and volume and particles. Well, now we're going to add Mole Town B. And I'm going to talk about when we would use this at the end. But as you can see, you have the exact same setup as the left-hand side of your mole map. So you have Mole Town in the middle, which can go to Mass Mall, it can go to Particle Plaza, and it can go to Volume Villa. You have the same conversion factors. So we have the arrows with the same conversion factors going in one direction or going in the opposite direction. So those are the exact same, but the difference is we now have Mole Town B in the middle. So previously we had Mole Town A, and now we're going to add Mole Town B. So you have to add this setup to the right-hand side of your paper of your mole map. Okay, it's going to look very, very similar, just the only difference is the A, and now we have the B. So think of this as two towns that need to be connected, okay? Previously, we had directions going in between moles and mass. We could convert between those. We can convert between moles and particles, and we could convert between moles and volume. Well, now we have to convert from moles to moles. Okay, we have to connect Mole Town A to Mole Town B. And in order to do that, we're going to add this conversion factor, which is called a mole ratio. So in the middle of your paper, I want you to draw an arrow connecting Mole Town A to Mole Town B. Okay, this arrow only goes in one direction. Okay, from Mole Town A to Mole Town B. The conversion factor that I want you to use is moles of B divided by moles of A. This is what is known as a mole ratio. So we have moles on top and moles on the bottom, but these are two different moles. And in order to find this, we're going to have to use coefficients from the balanced equation to create a mole ratio. Okay? In the next couple days, you all are going to learn how to create a mole ratio and how to do problems like this. Okay? So the new addition is the right-hand side of your mole map. This is a completely separate part, Mole Town B. Okay? Everything else, the setup is the same, and then we connect the two mole towns by this mole ratio. Okay? What your overall mole map will look like is this. So you have Mole Town A on the left, you have Mole Town B on the right, and then you have this mole ratio connecting the two mole towns. So up until this point, we were only dealing with the left-hand side. We can convert, like I said, between moles and mass using the molar mass conversion. We could convert between moles and particles using Avogadro's number. And then we could convert between moles and volume using that 22.4 liters. Now we're going to add in a second part, which is Mole Town B. And we can use this to go from one side, let's say Mass Mall, to the opposite Particle Plaza. So as you can see from this figure, there is no route to go from Mass Mall to Particle Plaza. There's no pathway. But we can now go from Mass Mall to Mole Town we can use our mole ratio to get from moletown A to moletown B, and then we can go from moletown B to particle plaza. And we take this route using the arrows, so we follow the arrows, we follow the direction of the arrows to get from our starting point to our ending point. Like I previously said, this week you all are going to learn about how to actually do the steps. But for now, I just want you to get this mole map done. Okay, so the thing we are now going to get into is, when are we going to use problems like this? When are we going to use the full mole map? So this is what I'm going to leave you off with. When would you use the full mole map? Well, let's say you had a question like this. How many grams of water are made from 20 grams of oxygen gas? And you have the balanced equation. 2H2 plus O2 goes to 2H2O. Now, previously, you dealt with one reactant, okay? One substance. Now, as you can see from our problem, there's two substances in the question. Right here we have water and oxygen. Okay? This is where you're going to use moletown A and moletown B. When you see in the problem two different substances being asked. Okay? So I'm going to leave you with this mole map. I want you to draw this on your paper because you're going to be using this for the upcoming week when we solve full-blown problems going from the left-hand side to the right-hand side.